evaluate this triple integral. Since we see x squared plus y squared plus z squared, we're gonna convert this into spherical coordinates, because in spherical coordinates we have x squared plus y squared plus z squared equals rho squared, just the distance from the origin. Now we need to convert these limits into spherical coordinates. Let's work first on z. So for g, we got lower bound g equals 0. That means this solid lies above xy plane, everything above xy plane, because the lower bound for g is 0. How about upper bound? G equals root 9 minus x squared minus y squared. That's the upper bound for g. If we square both sides of this, equals 9. So that's equation of a sphere, a standard sphere, okay, or ball with radius 3. Standard means the center is at 0, 0, 0 and radius 3. So the rho has limits, lower limit 0 and upper limit 3, because this is rho square equals 9, rho is 3. This is always positive, okay, less than equal to. So we have the limits for rho. How about x and y? Okay, the projection of the object or projection of the solid in xy plane. Let's look at that. X all the way outside here, that's the easy part, negative 3 to 3. So basically 1 to negative 3 here. So x is in between negative 3 and 3. How about y? Let's work on y now. Y is here, okay, so y lower bound is negative 9 minus x squared. That's the lower bound for y. If we square both sides and move things around, so we get a circle, standard circle with radius 3. Okay, so that's from the lower bound, and we get the same thing from upper bound. So upper bound is y equals 9 minus x squared. We get x squared plus y squared equals 9. So basically the projection of the solid on the xy plane is a circle. Okay, so we already knew the limits for rho. Rho has 0, 3. So in fact we can write the solid in this way. So the solid we are considering here, let's say the solid E is set of all x, y, z, but we are converting into spherical. So that means rho, theta and phi, such that rho is in between 0 and 3. And looking at this projection, we go 360. That means theta is 0 to 2 pi, and since lower bound for g is 0, so we are only considering upper part. So it's like the solid is just here, okay, up to 3. So the angle phi, which is measured from g-axis, so it's only pi over 2. Okay, the angle is pi over 2. So phi is 0 to pi over 2. Okay, then we can rewrite this triple integral in this way. From this dg dy dx, we get rho square sine phi d phi d theta, d rho d theta d phi, and the integrand here is the integrand is square root of rho square, okay, which is just rho, and the limits for rho because rho is inside 0 to 3, so rho from 0 to 3. Then comes theta, theta from 0 to 2 pi, then phi, that's 0 to pi over 2. Okay, now we need to evaluate this. The good news, these limits are all number limits. That means we can just do all three integrals at once. So that I meant p from 0 to pi over 2. Okay, there is sine phi, so we can just bring sine phi d phi here. And second part, theta from 0 to 2 pi, we have just d theta, so 1 d theta. And the third, rho from 0 to 3, rho and rho is square, rho cubed d rho. Okay, now this is antiderivative of sine is negative cosine, and we go from 0 to pi over 2. Here antiderivative of 1 is theta, 0 to 2 pi. Here is rho cube, so rho 4 over 4, 0 to 3. Upper limit is negative cosine pi over 2, which is 0, minus lower limit is negative cosine 0, so negative 1. Here 2 pi minus 0, just 2 pi. Here this is 3 to the 4th over 4, 3 to the 4th, that's 81 over 4, minus rho is 0, so this is 81 over 4, and this is negative minus 1, just 1. So 1 times anything, just that, and 2 divides twice, so 81 pi over 2, or 81 halves pi, same thing, final.